Hi, everybody. How's it going? How's it going? This room is wonderful, by the way. How many people, just by a show of hands, really love testing? It's a wonderful thing. You're here because you love it. That's great. I'm assuming most of those aren't sarcastic. What about hate testing? This is the bane of your existence. You're here because it's awful and terrible. And how many of you have just never tested? Unit tested, integration tested, test in production, yeah, any of the above? Okay, cool. Well, my name is Jake Dawkins, and I'm here to talk about all of the above, except for testing in production, hopefully. A little bit about myself. As Jesse mentioned, I'm an Apollo architect. I work on the Apollo team, and really just what that means is I'm here to help you navigate the GraphQL ecosystem and Apollo's tools, specifically around some ideas of best practices, schema design, and testing, thus the talk. These are things that we get special exposure to and unique exposure to working with some really large companies. Everybody does things differently, and seeing how people do things, it really gives us insight into how to make things better. So hopefully, if you haven't had experience with testing, especially with Apollo's tooling, whether it be on the client or server, this will be enlightening and wonderful for you. So what am I going to be talking about exactly? So I'm going to go into a little ideological sidebar, talk about the purpose of testing, the effectiveness of different kinds of testing, and then I'm going to go a little bit into the weeds and talk about testing your clients and testing your servers. So without further ado, let's get into some ideology about the purpose of testing. So a lot of people raise their hands. Why do you test? For me, it comes down to two main categories. There are other reasons. Everybody has their own preferences. But I like to think of the testing falling into two categories of safety of your production code, because you don't want to test things in production, have your users be the first ones to find bugs. That's generally a bad idea. And second thing that I think is often not talked about very much is documentation. I can't imagine, or I can't count how many projects that I've come into, and the documentation is kind of lacking, for lack of a better term, or in cases where I wrote the code, there just wasn't documentation, and it's been 3 months, and I have no idea what I wrote anymore. So where do you look? I think that tests, not only are they generally describing in plain text in the title what they're supposed to do, they also show you how to use the function and its expected behavior. So documentation, I think, is a really important aspect of tests that people often look over. Up next, talk about the effectiveness of tests. So I like to think of testing in the mindset of the Pareto principle. And for the 99% of people who don't know or care what that means, it just means that most of the time, 80% of the benefits you're going to get from something come from 20% of the work. In other words, you do 20% of the work, you get 80% of the benefit. In other words, the other 80% of your work isn't really wasted, it's just less beneficial than the beginning part. So for this talk, I'm going to try to focus around helping you choose what 20% to test, especially when it comes to Apollo's tooling. I would be a terrible presenter if I didn't mention Kent C. Dodds and his wonderful work around testing. He just released a JavaScript testing course, but he's also done a whole lot more. He proposed this idea of a testing trophy. So, we've all seen pyramids, food pyramid, testing pyramid, the two most popular ones. Great pyramid, whatever. And then we have this testing trophy, which kind of breaks up the value of tests, especially the return on value, by proportion. And what you really need to know from this chart here is that your static test, your static typing, static analysis is going to get you a lot of benefit, especially when it's automatic. The next most beneficial part of these tests is going to be integration tests. These aren't unit tests, which unit tests just test individual functions, individual components in isolation, whereas integration tests test how these pieces come together. I like to think of it as in saying, if you want more confidence in your code, you should be testing the parts of your code that you're least confident with or that are most likely to break. Because these pieces, while they might be the most difficult to test or the most intimidating to test, not only in doing so will you learn a whole lot about it, you will also be more confident in your code going into production. So for those reasons, I'm going to be talking a lot in this talk about integration testing. I will talk about the other forms of testing with regards to client and server applications, but integration testing will be my focus here. So let's jump off the sidebar and talk about testing clients. So when I talk about this, I'm mostly meaning testing React Apollo and Apollo clients. projects. These are using React as the view layer, for example. This is what I have the most experience with, so this is what I'm going to talk about. These ideas could transfer, but this is what I'm talking about. So first off, let's just talk about static typing and what it means for a React application. Generally, what we're talking about static typing is assigning types to props. So your components, they get props, and you're saying, hey, this prop is going to be a number, this prop is going to be an object, and defining the shape of that prop. Ideally, if we're talking about React projects that use Apollo and use GraphQL, what you're talking about is these types coming from your production schema. So since GraphQL is a strongly typed language, we know exactly what we're supposed to be getting back. We know when something might be null and might not be there, and we also know when they're definitely going to be there and when you can rely on it. The Apollo CLI actually, if you saw Jeff's talk this morning, he was talking about it, and Adam Neary showed some more automatic type generation. The Apollo CLI really helps with this, especially with your production schemas. You can also have the different versions of your schemas tagged differently for dev or otherwise. It makes this really easy to do. And I'll show more of these examples later on, but for now I'm just going to skip straight ahead to unit testing. I'll go through this and then show examples. Unit testing. This is just testing in isolation, so testing components, showing them in isolation. And I just like to think of this in React as usually as props in, render logic out. You may have some small interactions with these items, but generally if you're testing something in isolation, you're like, okay, I clicked the button, is it firing the function that's the prop? Like, it's not too in-depth of test with unit testing. For this, I would highly recommend React Testing Library, also by Kent Dodds. It is wonderful. All the examples that I will be showing will be using React Testing Library as kind of the scaffolding for it. But yeah, moving right along. There's also integration testing that you can do, and this is really just making sure all the pieces fit together. So you have all these units, all these tiny pieces. What happens when you try to render them together? What happens when one component tries to render all of its children? Does it crash and burn? Is it passing it the correct props? And really, this is also important because when you change those things in the future, you're also changing potentially how they interact with each other. And if you're not careful, you break everything in production. But there's also more to this. Not only do you have to figure out, is this rendering the right thing, you also have your loading, your error states, things that aren't really going to be at the front of your mind when you're developing, because you may have data mocked and it may be right at your fingertips, but in production, you're going to have a loading state almost every single time. You're going to have an error state maybe more times than you'd like, and these are things that you should definitely be testing for. One of the tools that we offer for this, especially in the React world, is a mocked provider, which if you're familiar with React Apollo, it works by wrapping your entire component tree in a provider that has access to things like the client and the cache. So whenever your query and your mutation components later on try to make a query and a mutation, they can look at the context and see, hey, here's our client. This is what we're actually using to make requests. So we provide this tool to make that a little easier for you. Next up, we have end-to-end testing. And this is a little bit outside of the scope of this talk, so I'm not going to go too much into depth with this, but this is making sure your app is usable. Starting up the app, generally inside of like a Chrome window or inside of a web environment, and making sure you can actually do things like log in. And then once you're logged in, hey, can I actually navigate? Like, are my authentication headers getting passed around properly? To make sure your app is actually usable, because unit tests are great and all, but if the app doesn't start up or the user can't log in, that's a pretty big problem. Cypress is a tool that's really great for this. It's a really great experience that I've used in the past, but I won't be showing an example specifically of that today. But speaking of examples, I will be showing a demo of some of the other things. And now, if I can hopefully get out of this and mirror my displays, give me 1 second. Lovely. Let me get this here. Get my terminal window back up. Okie dokie. Yep. Wonderful. Okay, is that visible? Can everybody see that pretty well? Okay, kinda? Yell if not. Good, awesome. So here's what we have. We have a very simple test that all this is going to do is render a single React component in isolation. This is an example of a unit test for React that I was talking about. If we want to look at this component real quick, because the VS Code is wonderful, I can jump straight to it. This is a very simple component. It takes in a site, it takes in a rocket, and it renders the rocket's name, the rocket type, and the site that the rocket is going to be launched from. This is actually a code snippet from our full stack tutorial that we published last night, and it is available for everybody to go check out. So if any of these examples I go through too quickly, feel free to hop on this later and check it out. It's really good. It's all still tested. The tests are published, and you can go run them for yourselves and mess around with them, copy, paste, whatever. So yeah, back at our test, we have this render function that we're importing from test utils, which I'll explain in a second. But all you need to know is this is the React testing library's render method. And down here, whenever I actually call this render method, I'm passing it our component, giving it some props, and it's going to render it to a DOM. And then I can make assertions against it, like try to get something by text, the Apollo launch pad, the Big Falcon Rocket 1, and then BFR, because we saw that all three of these things should be rendering. And if I hit save on this, you can see they rerun. I'm not just trying to do some magic here and just pretend like tests are passing. So yeah, that's a very simple unit test, rendering a component out, not going too crazy with it. Up next, we have something a little more crazy. We have a login page, which if I look at this one, this has an Apollo consumer component, which gives us access to the Apollo client so that we can update the cache later on. And we also have a mutation component here, and we're trying to log in a user, essentially. The login form is just UI, so it's not that important for the sake of this talk. All we know is that we're passing it a mutation called login, and that login form can then call it whenever the user clicks submit. So what are we wanting to do here? Well, step one, we just want to make sure that it renders. Like, this is making a mutation, so it's not going to immediately make a query or anything. Like, all we want to know here is that it renders first off so that we can actually click the login button, right? So let's go back to our login example test here, because this isn't the full login test, see? So we have this render component still, and if we try to render our login page just by itself, and I'm going to unskip this so you can see it, it'll fail, and it'll give us a pretty nasty error. If I scroll all the way up to the top, it says, could not find client in the context of Apollo consumer. And that has to do with the fact that the thing that I mentioned a minute ago is that at the top of your tree, Apollo's query and mutation components are always looking for that Apollo provider. And if you don't have it, you're not going to have a good time. You will get this. So on this next test down, you can see that I take this mocks provider that we have, which mocks out the client and mocks out the cache, so you don't have to manually do that stuff yourself. And then you can also pass it an array of mocks, which I'll explain in a second, but for right now, I'm not going to worry about it. I'm just trying to get this thing to render, like I said. So now, if I save this and run this test, test pass, right? Oh, yay. And then we can check to make sure the login button actually shows up. So this is great and all, but there's a little bit more, because what happens if you click the button? Does it explode, or does it actually log you in? So let's check that out. We have this much more involved test here, log in, and that mock provider logic that I had just then, like where I'm actually taking mock provider and wrapping the component with it, I made a custom renderer in React test renderer, or testing library, and it's called render Apollo. And that's all it's doing is this login component here is the exact same test as the last test I showed you. It's just wrapping this login with a mock provider. I just did that to save time, considering if you're writing 100 of these things or more, then you don't want to have those 2 lines every single time, because that gets really cumbersome really quick. So you can see that I'm still testing this. If I were to break this, then it would break these tests on the right. But this is the same test. So what happens if I want to click it? Well, a couple of things. So whenever I click it, it's going to fire off a mutation. I showed you the mocks array a second ago that you can pass to the mock provider, and this is actually really powerful. So what the mocks do is they act as a matcher. So anytime that this request here gets made, in other words, anytime this login user mutation gets fired with these variables, a at a.a, great email, then it's just going to return this email. The mocked Apollo client instance is going to return it, and your component is going to see this response. The data with login ABC, this is a login token. It's a horrible login token, but nonetheless. So yeah, then we get down here to render Apollo. We render our login component, and we pass it our mocks, and we also are going to pass it an instance of the cache that we just instantiated right here, just so we can check it later and make sure that the cache updates that I pointed to actually happen. So yeah, then fire event is something that comes from React testing library. So I can fire a change event on the login input, type in our super secure email, no password because security is unimportant, at least for this app. quote. And then I'm going to click the login button. And what's going to happen then is the component's going to enter the loading state. So this mock provider, it actually does trigger the loading state in your components, so you can test that. And then what I'm going to do is I'm actually just going to wait until the login button shows back up. Now in the app, like the login button wouldn't show back up because you're getting redirected back to other parts of the app. But when I'm talking about this component finding this mutation, unless I were to redirect, this button would just show straight back up. So I'm just waiting for the button to show back up to know that my mutation finished. And then afterwards, I'm taking that cache instance that I had above, and I'm running a query against it just to see if my isLoggedIn was updated. And if I change this to like isLoggedIns, then this would fail. And it would say, yeah, isLoggedIns is not on the type object of root, or is not on root query. In other words, saying, this isn't in the cache, what are you doing? But if I do test it, I can pull off the isLoggedIn object from the response of this query, and I can check to make sure that it's true. So in other words, the login worked. So that is just a really quick run through. There are quite a few more examples of this in the project that you can go look at yourself. But for the sake of right now, that's all we're going to look at. And please give me a moment while I unmirror my displays. This might not work very well. Where did it go? Yeah, there's Google Chrome. Come back. Thank you. All right. Now, on to testing servers. This is one I'm actually really excited about because we haven't written an article about this one recently. I actually wrote the testing Apollo or React Apollo's query and mutation components a couple months ago. So these are things that we've already gotten feedback on, already talked about a good bit publicly. Whereas testing services is something that everybody kind of has their own idea for right now. Especially like static typing is one thing that people generally say. It's like, yeah, this is a really easy thing to do, right? I mean, you have your static types, you know what your resolver is going to be returning, right? But then it gets more complicated, and that type generation for resolvers especially isn't that straightforward, at least not to do automatically. You can definitely type your resolvers, but the problem with typing them automatically is that resolvers aren't required to return anything even recognizable to the user until the very leaf. So like the very end of the execution is when resolvers are actually expected to return something that's like consistent with the schema. Resolvers along the way don't have to return anything. They can return anything, and it's really hard to generate types automatically for that unless you enforce some restriction saying like an object type has to return a JavaScript object in the shape of the type that it's returning, which you can do. Like that's fine, but default resolvers also make this hard. Like if you were to return that from a parent and you just return the correct shape and not provide those child resolvers period, then you don't have to type them because they don't exist, but you do have to type the parent correctly. So you have this weird world where you can kind of do anything you want with the resolvers. Up next, unit testing is actually something that's very enjoyable. It can really leverage GraphQL's dependency injection very well. And the reason, and I'll talk about like what this is in a second and why this is important. But at the end of the day, testing resolvers and data sources are pretty simple because resolvers are just functions and data sources are just classes. So if you've ever tested a JavaScript function, you can test resolvers as long as you're using dependency injection wisely. The next part of this, which is something that's new that we've actually been working on I've been working on for quite a while, trying to figure out how people do this right now and how they want to do this, is integration testing. And what I mean by integration testing is testing the execution of an operation, not testing expresses like HTTP semantic logic or anything like that. I'm saying, given an operation, does it run through all the resolvers properly? Does one resolver pass the correct information to the next one, all the way down the chain? And is the response somewhat regular like we expect to see? So a tool that I'll show in a second that we've actually built for this is called Apollo Server Testing. You can install it just like you install any other Apollo Server instance or integration, like Apollo Server Express, Happy, Koa, anything you want. So I'll show that in a second, but before I forget, end-to-end testing is also very possible with this. This actually does check the HTTP semantics and all the fun that comes with that. You have to provide actual HTTP requests to it, and you actually have to start up a real server. So I'm just going to show how to do all those things. Easy, as easy said as done. Let's see, hop over here, bring up my terminal once again, and here we go. Cool. So this is in the same project. This tutorial is all in the same project. But I'm going to show you how to test this login mutation that we just ran on the client side. So if I actually open up this resolver real quick so you can see what it looks like, It's a relatively short resolver. What it's doing is it's taking an email argument and it's taking a context object which has data sources on it. And this is what I was talking about with dependency injection, is that other than buffer at least, which is a node thing, other than that, this function, this resolver, only uses things that are passed to it as arguments directly. Same thing with every other resolver in this file. We're not actually importing anything at the top of this file and using it inside the resolvers, because that makes it a little bit harder to mock. And most of the time, you can pass these things through as arguments, whether it be on the context or actual arguments to a GraphQL operation. So yeah, here it's just looking up a user from the user API data source, and if the user is there, then it's returning a token back to the user so they can make authenticated requests. So let me get rid of that. So back to this test. So this test is just checking to see if it returns a base64 encoded email if successful, because these tokens are very secure. So what we're doing here is we have these mocks at the top of the file, and these are all jest function mocks, and I'm just mocking the return value of this finder create user, which exists on datasources.userapi.finderCreateUser. It's the same function that the resolver was calling. I'm mocking this to just return true once, just to simulate, hey, we looked up a user, and they exist, I promise. And then we're actually just running the resolver. So I just imported the entire resolver map from the other file, and I'm just calling resolvers.mutation.login, and I'm passing it nothing for the parent type, because it doesn't need one. I'm passing it an email, super secure email, and I'm passing it our mock context, which includes this data source and which includes this mock. And then all I'm doing is I'm just checking to make sure that the result of that resolver is the correct thing. It's that simple. And I'm also doing like an extra step here, and I'm saying, was the data source actually called with the correct function or the correct arguments? You don't have to do that. I do that just because I like testing, and that's just who I am. So love it or not. Hop over to a data source. Very similar idea. This data source is a REST data source instance. It's making requests, straight to a SpaceX API. So, for example, for this launch API.getAllLaunches, it looks kind of similar. I'm mocking the actual underlying get function on that data source, because I have the instance of the data source. So I can just say data source.get, and I can mock that. I can override it just for the sake of this test. And what that allows me to do is it allows me to still test to make sure that I'm handling the response properly. It still allows me to make sure I'm transforming that, that raw REST API request properly. And then I can just call the data source's method, and then I can make sure that it equals our formatted mock launch like it's supposed to. This is a really good pattern, and it works pretty well. I've done this quite a good bit. And same thing, I can then call and make sure that the underlying get, the fetch implementation is being called with the proper URL. This works well, but there's another step that we have to go into. I promised integration tests, so here we are. This is actually something that's kind of fun. I built this tool and with the help of people, and it's really fun to use personally. So I'm going to do it. Ignore this knock. That's not supposed to exist because we're not actually mocking the HTTP calls at all. So let's take a look at this. Where did that go? I'm not going to do this first one because it's really commented. You can go look at this one later. It's the integration test file at the root of the repo. So yeah, let's look at this. This is saying fetches a single launch. And what this is doing is a couple of things. First off, this function here, construct test server. This isn't part of the Apollo server testing. This is just a function that I wrote. I'll actually show it to you. Oh my goodness, there we go. Here we are. Construct test server, all it's doing is it's taking our user API, our data source. It's taking our launch API, our other data source. It's instantiating them and just passing them to a class instantiation of new Apollo server. This is just to make sure that we're not having to use like our production Apollo server class instance, because usually in integration tests that's not going to be feasible. We want to mock some things. So we're reinstantiating a new instance of Apollo server. We're passing it our production type defs, our production resolvers. We're passing it a context function that we're either saying default context is like, yeah, we want to use the server's actual context function. Otherwise, we just want to use an overwritten one that we can write. And then data sources, just as if you were instantiating an actual Apollo server class, we're just passing some data sources along. So that's what construct test server does. You don't have to have a function for that. I just didn't want to write this multiple times. So If I go back down to my test, construct test server, it returns the server. So if you said new Apollo server, whatever the return of that is, that's what this is. And it returns our 2 data sources. And the reason I did it like this is because I wanted to actually access those data sources. So I could do the same thing, mock those underlying bottom level, bottom of the stack get calls. I can mock those actual, in this case, those SQLize, find all functions. I can actually mock those if I want to, so I don't have to, actually spin up an in-memory instance of SQLite, or, if you're using something, a little heavier like Postgres, you don't actually have to spin up an instance of Postgres for this. I'm just mocking that, but leaving the rest in stock, leaving the rest in place. So leaving all the data transform logic, leaving everything else in place. And then here is the part that we exported from the Apollo server testing library. It's this create test server. So what does this do? Let's take a look. Create test server? No, wait. Yeah, this thing. Keep going. Yeah. So this is a little more complicated. Essentially, it exports the return of this is 2 things. It's a query and a mutate function, and these kind of look similar to Apollo client. If you've ever used like the client dot I don't like that client dot whatever like client dot query, and you can pass it a query and then whatever your query name is. This is what that looks like. It also allows you to pass variables along, which you will see in just a second. I hope I didn't break anything by editing that file, but we'll see, because live coding is great. Let's get back down to it. Yeah, so I'm getting query from that create test client, and what this actually does is some of the things talked about this morning with Apollo Server 2.2 is a new request pipeline. And Martin Walraven going to be talking more about that tomorrow, but this is a new execution model for Apollo Server and how it actually runs queries. So we actually added in a utility, if you saw it at the top of that file, I don't think it's still open, no, called execute operation to the base class of Apollo Server, so you can actually call queries directly from the Apollo Server class. So that's what this is doing, is it's running an operation against the class, running everything through the real request pipeline, giving you exactly what you should get from Apollo Server. So then if I take this query and I run an actual query against it, our get launch query for this example is just up above here. Query launch, it gets passing variables through. It has an ID. It has an isBooked, which is actually looking up from the SQLite database. We have a rocket. It's not a trivial query. It does a couple things from multiple different data sources. And if where'd that go? Yeah. If I run this test, it'll actually write it a snapshot because I didn't feel like writing these tests in line. But if I go look at it, snapshots.integration, book trips, fetch is list of launches. I wrote a lot of these because they're fun. Single launch, this is what it actually returns. It returns data, and data is an object that has launch ID is booked true on it because this is actually something that was written to the database. It returns the mission with the Falcon satellite, and it returns the rocket. So this is as good as you're going to get with integration testing. It hooks directly into Apollo Server. It gives you exactly what you want with the exclusion of the HTTP semantics and the actual REST lookups or the actual database lookups. This is everything in the middle. So what if you wanted to do everything else? What if you wanted to test with real queries? This isn't part of Apollo Server testing, mostly because there are a lot of Apollo Server integrations, and I didn't want to write one and maintain one for every single one of these, because it's a little bit different for every single one. But I have this start test server function that I wrote, and you can do the same thing. It's not a lot of code, so if you wanted to copy and paste it, not that bad. I left in the code here if you're using Apollo Server Express, the top lines that you would do. But for example, what this does is it takes an instance of Apollo Server. This can be your production instance if you want, especially if you have a staging environment set up with your databases, with your underlying services. If you have a staging environment, this is all that you need. And what it's doing is it's starting the server on a dynamic port, so it picks a port, and it creates a new Apollo HTTP link, and then it actually calls the execute function with that link with your query and variables. So this is testing everything that there is to test. This is testing the HTTP semantics. You can pass it headers. This is testing the entire execution pipeline that we showed in the last integration test. This is testing the actual underlying fetch calls. This is testing everything that you can test. And these tests are actually even shorter than the last one. Like get list of launches, all I'm doing is I'm calling this exported GraphQL function from that with a query, with some variables, and then I'm snapshotting the results. And I'll show you those to prove that they exist. This list of launches, I forced it page size 1, so it only showed me one, so I don't have a huge snapshot to show on stage. But this is what it is. It shows you a launches array, and it shows you individual launches with missions, mission patches, and names, because that's all we asked for. So let me hop on back to my slides, if I can. Let me see here. Where'd it go? There we go. On mirror displays. And there we go. Back to that, and back to this. Delightful. OK. My parting words is I want to say that testing is essential, especially for large companies, especially for large projects. Testing is essential. So it should also be easy, and it should also be effective. And that's what I'm here for. That's what we're here for. We're here to make these tools. We're here to maintain them. We're here to make your lives a little bit easier. So maybe a few more of you would raise your hands and say that you like testing. So yeah, that's all I have for you. I hope you check out the projects, and thank you so much for your time.